You remember the first time you heard its name, 3IATLAS. No numbers, no familiar orbit, no reason it should even be here. It appeared in the dark of space just beyond Mars' orbit, a fragment of light cutting through the void like something that wasn't supposed to exist. Telescopes blinked awake, data poured in, and what scientists saw didn't fit anything. Its trajectory wasn't circular or even elliptical. It was hyperbolic, a path that meant it wasn't from here at all. This object, this visitor, wasn't bound to the sun. It was just passing through. For astronomers, that realization hit like thunder. It meant this thing came from another star. And that's when the questions began. Where did it come from? What sent it here? And why, after billions of years of silence, did it arrive now? The first time light from 3IATLAS reached Earth, it was faint, almost imperceptible, a whisper across the cosmic sea. Yet within weeks, that whisper turned into a message loud enough to echo across observatories worldwide. On April 15, 2025, the ATLAS survey team in Hawaii recorded a strange, moving point of light. Not an asteroid, not a comet, something different. Its speed nearly 64 kilometers per second, its orbit cutting across the ecliptic as if defying every gravitational rule we know. And it wasn't slowing down. By the time NASA confirmed the trajectory, the world's telescopes were already turning toward it. It was the third confirmed interstellar object to ever enter our solar system after Oumuamua in 2017 and Borisov in 2019. But this one felt different. Borisov was a comet, icy, predictable, leaving a tail behind it like a postcard from home. Oumuamua was strange, flat, fast, reflective, but it came and went before we could even focus. 3IATLAS, though, this one lingered. Its path threaded between Jupiter and Mars, gliding silently through the inner system. And the deeper it came, the brighter it got. Not from reflection, but from something else. Something active. Something alive. At first, scientists dismissed it as coincidence, maybe the angle of sunlight, maybe a miscalculation. But night after night, the data said the same thing. 3IATLAS wasn't behaving like a rock. It was acting like a signal. We're used to thinking of comets as frozen time capsules, relics of the early solar system. They drift, they evaporate, they die. But this one had energy, movement, purpose. When the European Space Agency pointed its infrared arrays, they found heat far more than expected at that distance from the sun. That shouldn't have been possible. And yet there it was, glowing in wavelengths that made no sense. The scientists tried to reason it out. Chemical outgassing, maybe. Micrometeor impacts. Or a magnetic reaction. But the truth was stranger than all of that. Because when Hubble locked on for its first clear image, it didn't see a typical comet at all. No bright tail, no gas plume, just a strange diffuse glow around an object that refused to look like anything else. It was as though it were cloaked, surrounded by an invisible veil. And that's when whispers began. Maybe it wasn't a comet, maybe it wasn't even natural. Some called it the messenger, others called it the mirror. But to most astronomers, it was simply impossible. Still, the numbers didn't lie. Its hyperbolic trajectory meant it came from beyond the stars, and one day it would leave again, never to return. In a universe that measures time in billions of years, that's like a single breath, a fleeting encounter with something that may never happen again. And yet it's here, now, floating between Mars and the sun, bathed in the light of a star it never belonged to. The last object like this we found, Oumuamua, came and went in weeks, but 3IATLAS stayed. It slowed, it brightened, it waited as if watching. And while it waited, the sun began to change. Increased solar flares, new sunspots emerging at record speed, as if the star itself was responding. Coincidence, maybe, but the timing was eerie, too perfect to ignore. In ancient times, people would have called it an omen, a herald of awakening skies. In modern times, we call it data, but data too can feel like prophecy. Because 3IATLAS, whatever it is, has already begun to rewrite our understanding of what's possible. And this is only the beginning. You remember that first glimpse of 3IATLAS, the silent traveler cutting through the solar dark. But what scientists found when they looked closer defied almost every expectation they had. It wasn't just another icy wanderer. It wasn't behaving like a comet at all. It was breaking the rules one after another. When Hubble and Webb both turned their eyes toward it, they caught something extraordinary. You'd expect a comet's tail to stream away from the sun driven by heat and solar wind, but the tail of 3IATLAS pointed toward it. It was like a candle flame bending backward, as if the sun's light were pulling it closer instead of pushing it away. The first reaction from NASA's data team was disbelief. Dr. Martin Cordner, an astrochemist leading the analysis, reported that the gas surrounding the object, its coma, wasn't made primarily of water like every other comet we've ever studied. Instead, it was rich in carbon monoxide and carbon dioxide, even though it was far too cold for those gases to behave that way. Something about the object's chemistry was rewriting the textbooks literally overnight. Hubble measured its size, the nucleus. The solid heart of the object is no more than 5.6 kilometers across, smaller than scientists first assumed. But it was bright, far too bright for its size. The glow didn't make sense. It was as if the entire comet was alive, reflecting more sunlight than it should. Some thought it might be covered in reflective ice crystals. Others proposed that the brightness came from the way dust was being ejected, not evenly, but in unpredictable bursts, almost like breathing. Every few hours, its light pattern shifted slightly, as if something inside it was rotating, pulsing, responding. And the strangest thing, it wasn't random. The changes followed a rhythm. 16 hours, then 29, then back again, almost like a heartbeat. Astronomers using the TESS telescope went digging through old data and found that 3IATLAS had already been glowing months before it was officially discovered. They estimated that its brightness had increased 5 times faster than expected, not by reflecting sunlight, but by generating energy from within. It wasn't just reacting to the sun. It was doing something more complex, as if it carried a source of power deeper inside, something ancient, something intentional. Now let's be clear, no one's saying it's alive. But whatever process is happening inside 3IATLAS doesn't match any natural model we know. Think about that for a moment. This object came from another star system, and yet it behaves in a way that doesn't even make sense within its own physics. If that doesn't make your mind spin, nothing will. On August 6, 2025, the James Webb Space Telescope recorded the most detailed infrared spectrum of 3IATLAS yet. The data revealed a mix of gases no one had ever seen from a comet this far out. It was venting compounds that usually appear only after an object gets close to the sun, and it was doing it way out by Mars. That shouldn't be possible. To give you a sense of scale, most comets begin waking up around 3 astronomical units from the sun. 3IATLAS was active at 6 AU, nearly twice that distance. It's as if a frozen rock in deep space suddenly decided to warm itself up. And so the question arose, what could trigger this? Dr. Karen Meach from the University of Hawaii described it perfectly. This comet doesn't just react, it anticipates. It starts to move before it's touched. Her team proposed that volatile elements, perhaps nitrogen, hydrogen, or even exotic ices from another star system, could be responsible. But there's another theory, one that keeps resurfacing. The idea that maybe 3IATLAS isn't entirely natural. Now before you roll your eyes, hear this. In 2017, when Oumuamua was first discovered, it too behaved in ways that made no sense. It sped up without any visible jets of gas. It rotated erratically, reflected light unevenly. Harvard physicist Avi Loeb famously suggested it could be a piece of alien technology, perhaps a defunct probe drifting for eons between stars. His paper was controversial, but it opened a door. And now with 3IATLAS, that door just creaked wider. Loeb pointed out something fascinating. The odds of finding 2 interstellar visitors within a single decade were astronomically low unless our galaxy was full of them. And if there are many, then what are they doing here? NASA and the European Space Agency remain cautious. Their official stance, 3IATLAS, is a natural body, just an unusually volatile one. But deep down, even the most skeptical scientists admit that it's strange. Very strange. When analyzed for light polarization, The way sunlight scatters off its dust, 3IATLAS produced a negative polarization signature unlike anything we've ever seen. Not even Borisov, not even Oumuamua behaved like that. To put it simply, the light isn't bouncing off this thing normally. It's bending, twisting, as if the surface has a structure, something fine, deliberate, perhaps engineered. But again, no one can prove that yet. And that's what makes it so intoxicating. Every time a telescope captures a new frame, every time a computer refines a trajectory, it leaves us with more questions than answers. Is it a comet, an ancient shard of a long-dead planet, a piece of cosmic machinery, or simply a mirror showing us how much we still don't understand? And here's the part that hits hardest. If 3IATLAS really is billions of years old, then it has seen galaxies collide. It has watched stars be born and die. It has passed through regions of radiation so intense that no life could ever survive, and yet it endures. Every tiny scar on its surface is a timestamp in cosmic history. And maybe, just maybe, it carries within it the blueprint of creation itself. NASA's newest models suggest the material making up 3IATLAS contains amino-like compounds, the precursors of life. If confirmed, it could mean that interstellar travelers like this one have been sowing the seeds of biology across countless worlds, including ours. The idea is ancient, called panspermia, but now for the first time, we might actually be seeing it in action. So the mystery deepens. An object that shouldn't exist behaving in ways that defy physics, carrying chemicals that could spark life. And all of it right now passing quietly through our own neighborhood in space. You can almost feel the irony, can't you, that something older than time itself is drifting by while most of humanity doesn't even know it's there. But for those who do, for those looking up tonight through their telescopes, it's a reminder. The universe still holds secrets that even our most advanced science can't quite explain. Not yet. The story of 3IATLAS is just beginning. And the next revelation might come from the unlikeliest of places, not from the great space observatories, but from a small cluster of telescopes on Earth that caught something no one expected. A signal, a pattern, a pulse. There's a kind of silence in space that you don't hear, you feel. It's not empty, it's alive. And sometimes if you listen closely enough, that silence pulses. That's exactly what astronomers felt when they pointed their instruments back toward 3IATLAS, the interstellar wanderer now nearing its closest approach to the Sun. By late September 2025, the object had disappeared behind the solar glare. No visible light, no new images, just static, a blank patch of sky. But in that silence, something stirred. It started with a small array of radio telescopes in the Atacama Desert of Chile. The facility wasn't even built to study 3IATLAS. They were scanning the sun's background noise for solar flares testing equipment during the US government shutdown when someone noticed a repeating pattern buried in the static. It wasn't strong, barely above the noise floor, but it was there, a rhythm, a faint beat repeating every 43 minutes. At first, the scientists thought it was an artifact, a glitch, a calibration error. But then, another observatory half a world away in Spain detected the same signal at the same frequency. That was no coincidence. Both teams went silent. They didn't announce it publicly, not yet. They compared data timing, polarization. Every variable matched. The signal was real. And here's the part that gave even the most skeptical astronomers chills. The signal's source lined up perfectly with the calculated position of 3IATLAS as it passed behind the Sun. Something out there, something beyond our system, was pulsing in perfect intervals. For the next 48 hours, the global network of radio telescopes came alive. Australia, South Africa, Japan, every facility capable of deep space observation pointed their dishes toward that invisible point. The result, a consistent pattern precise enough to defy randomness. Not a natural quasar, not a pulsar, not background cosmic radiation. The frequency shifted slightly over time, as if modulated, as if controlled. When the data reached NASA's Deep Space Network, the analysis team labeled it Event A217, a placeholder name, something to file to examine later. But the researchers who worked on it started calling it something else, the heartbeat. For weeks, the heartbeat continued, a quiet rhythmic pulse rising and falling in amplitude like a living thing breathing through light. Some scientists proposed it was caused by outgassing periodic jets of gas venting from the comet's surface, triggering electromagnetic interference. But the timing didn't add up. The pattern was too stable, too clean. Natural processes don't hold precision down to milliseconds. Machines do. Still, no one wanted to jump to conclusions. The ghost of Oumuamua still lingered, the controversy, the headlines, the accusations of sensationalism. This time they would be careful, quiet, methodical, but the truth has a way of escaping. By early October, leaked internal memos from the European Space Agency hit the internet. One document described consistent modulated emissions aligned with interstellar object 3IATLAS. Another mentioned non-random phase patterns in microwave frequency bands. Within hours, the phrase "the pulse beneath the silence" was trending worldwide. Now, for most of the public, this sounded like science fiction. Another alien signal, another false alarm. But inside observatories, behind closed doors, the mood was different. Dr. Elise Morano, a systems engineer at ALMA, described it best. It's not about whether it's artificial or not. It's about how something this far out can be so precise, so patient. Because the signal didn't demand attention. It didn't scream through the void. It whispered, like something ancient that had been waiting for us to finally notice. NASA's infrared spectrographs, still tracking 3IATLAS through reflected sunlight, picked up subtle fluctuations, small increases in brightness, synchronized with the radio pulse. Light and radio, dancing together. If it was coincidence, it was the most poetic one the universe had ever written. But let's stay scientific, because every time wonder enters the room, doubt follows close behind. A group from Caltech ran simulations. They modeled everything: solar, wind, electromagnetic reflection, ionized gas dust fields. After 3 weeks, they found only one possible natural explanation: a rotating magnetic field inside the comet's plasma coma that could maybe create an artificial beat through interaction with solar particles. But even that required precision far beyond anything ever observed in a natural object. One researcher called it a piano tuned by chaos that somehow plays a song, and that phrase stuck. The song of 3IATLAS became the obsession of a generation. Colleges streamed the raw signal. Podcasters layered it into ambient music. Meditation channels claimed you could feel the vibration through your body. For a brief, shimmering moment, science and spirituality met halfway in a pulse that neither could explain. Light and sound, silence and rhythm, matter and meaning. And through it all, 3IATLAS moved quietly onward, its course unchanged, its mystery deepening. Then came the moment no one expected. On October 25th, just days before its perihelion, the pulse stopped. Completely. No fade out, no gradual decline, just gone. The signal vanished as if someone flipped a switch. And for those who had been following it, scientists, enthusiasts, dreamers, the silence that followed felt heavier than before. But 2 days later, something even stranger happened. When the James Webb Telescope resumed scanning the area near the sun's glare, its sensors picked up a faint afterglow, a diffuse ring of infrared light surrounding the projected path of 3IATLAS. A perfect circle, uniform, expanding outward at exactly the same rate light would travel from the moment the signal stopped. It was as if the final pulse had left an echo, a ripple spreading through the vacuum. Not a signal, not radiation, something else. An imprint. That ripple is still expanding today. It's weak, barely measurable, but it's there. And that's the paradox. For all our instruments, for all our data, we still don't know what we're looking at. Is it a magnetic phenomenon? An interference pattern? Or something entirely beyond our understanding of physics? Dr. Avi Loeb wrote in an essay soon after. When the unknown whispers, our first instinct should not be to shout it down, but to listen longer. And maybe that's what 3IATLAS is teaching us. Not that it's alien, not that it's divine, but that silence itself is part of the message. In the months since NASA's official report classified the pulse as an unresolved signal of probable plasma origin, a phrase that sounds scientific and yet says almost nothing. But among the people who heard it, who watched the waveforms dance and vanish into stillness, there's a feeling that something changed. It wasn't proof, it was a reminder. That maybe the universe has been talking all along, and we just never learned how to listen. Because every great discovery starts with a sound you almost ignored, a flicker in the data, a heartbeat beneath the noise. And sometimes that's all the cosmos needs for someone to care enough to stop and listen. For days, the universe held its breath. After the pulse vanished, silence returned, a silence so heavy it felt deliberate. But then, something stirred in the one place that had always seemed too bright to hide anything, the sun itself. At first, no one connected the events. Solar flares happen all the time, and the sun is never truly still. But this was different. October 26, 2025, just 5 days after the last detectable pulse from 3IATLAS, the Solar Dynamics Observatory recorded a flare unlike any seen in the past decade. It erupted from a magnetic cluster that had rotated just beyond Earth's view, the very side of the sun facing directly toward 3IATLAS. It wasn't the size of the flare that shocked scientists, it was the rhythm. Inside that chaos of light, inside the roaring energy waves and plasma arcs, the flare pulsed, exactly 3 times, each pulse lasting 43 minutes apart. The same pattern that had once echoed from deep space. Solar physicist Dr. Eliza Kern described it as the most precise imperfection I've ever seen. When you zoomed into the magnetic data, the field lines twisted, snapped, and reconnected in synchronized bursts, not random turbulence, but a repeating beat. NASA's team initially dismissed it as coincidence, until the pattern appeared again 2 days later in a smaller, weaker flare. It was as if something was whispering back. By now, even the skeptics grew uneasy. ESA's solar orbiter, then positioned between Earth and Venus, captured coronal mass ejections from that same region. Inside the dense stream of plasma, there were harmonic oscillations, pulses of electromagnetic variation, matching once again the timing of the heartbeat. Yet, coincidence had stopped being convincing. On the night of October 29th, the day of 3IATLAS's perihelion, its closest pass to the sun, the solar wind surged. Sensors across the planet registered a wave of magnetic noise, unlike anything since the great geomagnetic storms of 2003. Power grids flickered in North America, auroras swept as far south as Rome and Texas. The sky turned green, then purple, then gold. And amid that light, for a brief window of 18 minutes, the magnetic frequency mirrored the same waveform recorded weeks earlier from the 3IATLAS pulse, as if the sun was replying in the only language it knew. It's easy to romanticize it, to think of cosmic messages and universal consciousness, but the scientific implications alone were staggering. For the first time, a correlation had been observed between a distant interstellar object and solar electromagnetic behavior. When researchers from the Max Planck Institute cross-referenced timestamps between the observed flares and 3IATLAS's projected position, they found the probability of random alignment was less than 0.004%. Dr. Ryo Watanabe, a solar plasma specialist in Japan, summarized it bluntly. If this is coincidence, it's the most eloquent one in cosmic history. But maybe the most beautiful discovery wasn't in the data, it was in the light itself. Satellites measuring solar irradiance detected a subtle fluctuation, a faint dip like a breath being taken. And for exactly 43 minutes, solar brightness dimmed by 0.06%, then returned. That's the kind of variation you can't see with the naked eye, but the instruments felt it, a pause, a shimmer, and then light resumed. When graphed, the waveform looked eerily like a heartbeat monitor, not jagged or chaotic, but steady, alive. The sun, the giver of all life on Earth, seemed to echo back the rhythm of something born beyond it. Of course there were explanations, always are. Some scientists claimed the observed flare patterns were merely a resonance effect, a byproduct of rotational harmonics within the sun's magnetic field. Others argued that the simultaneous aurora surge was pure coincidence timed with an unrelated solar cycle peak. But there were voices, quiet but persistent, who refused to dismiss it so easily. Among them was Dr. Aiden Solberg, an astrophysicist from Norway, who wrote a paper that would later go viral, Helios as receiver. Could the sun record interstellar information? His hypothesis was simple, not that the sun thought, but that it responded. If light carries data, he wrote, then the sun is both the source and the mirror. Every particle it absorbs leaves a trace. Perhaps 3IATLAS didn't speak to us, it spoke to the star that birthed us. The paper was ridiculed at first. Then it was studied, and slowly it started to make sense. Because if 3IATLAS truly carried materials older than our own solar system, carbon structures, nitrogen traces, amino-like chains, then the sun's reaction could have been chemical as much as electromagnetic. Dust and plasma meeting after billions of years apart, two fragments of the same cosmic memory touching again for the first time since the beginning. On November 3rd, the pulse appeared again, not from space this time, from the sun. Solar instruments registered a rhythmic modulation in the background X-ray flux, so faint it was barely above noise threshold. But it matched. 43 minutes, the same pattern, and this time it lasted 12 hours straight. No flares, no storms, just a steady, calm vibration woven through the sun's radiation field. To most of humanity, it went unnoticed, but those who tracked it felt something profound, as if the universe had exhaled, as if a message had been received and quietly understood. NASA officially categorized it as a low-frequency quasi-periodic oscillation, but inside the unofficial circles, astronomers, poets, dreamers, it gained another name, the Reply. The idea spread like wildfire online. People around the world synced their meditation timers to the 43-minute interval, believing they could tune into the sun's vibration. And in a way, they weren't wrong. Because rhythm connects all things, heartbeats, oceans, stars. It's the pattern life never stops following. And in that moment, as 3IATLAS moved past perihelion, trailing its mysterious dust into the void, our star joined the rhythm. For the first time, the sun and an interstellar visitor sang the same song. We may never know whether it was coincidence, a natural resonance, or something more intentional, something ancient echoing across light years. But one truth remains: the sun responded, and humanity listened. Maybe that's all the universe ever wanted, not worship, not control, but awareness. To be seen, to be heard, to be remembered. And as the solar light calmed, as Earth's auroras faded and the world slipped back into its quiet routine, something lingered, a question without an answer, a silence that hums softly beneath the daylight. Because once light learns to listen, darkness never feels the same again. The universe, it turns out, remembers things not in words or symbols, but in particles of dust. And tonight that dust is burning again. When the orbiters turned away and the signal from 3IATLAS faded, most assumed the story was over. But back on Earth, in a clean room outside Tokyo, a team of astrochemists at JAXA wasn't finished listening. They had something no one else did: a sample. It wasn't from the comet itself, of course. It was from the solar wind. A wafer-sized collector that had been orbiting near Mars had captured traces of fine particulate dust that matched the chemical profile of 3IATLAS's tail. When they analyzed it, they found something extraordinary. The particles weren't like ordinary cosmic dust, chaotic, irregular, scattered. These were layered, thin sheets of carbon stacked with precision, each layer separated by microscopic filaments of nitrogen compounds. Under an electron microscope, the structure looked alive, like the scales of some long-forgotten creature that had once swum through fire. Dr. Keiko Narahara, lead chemist on the project, stared at the images for hours. Then she whispered, "It's self-organizing." The lab fell silent, because that phrase, self-organizing, isn't one you throw around lightly. It means that under certain conditions, the particles behave as if they're following instructions. They align, bond split, and reform, all without any external interference. No one dared say it out loud, but the word proto-life hung in the air like static. To test the theory, they simulated solar heat inside a vacuum chamber, recreating the temperatures that 3IATLAS would have experienced as it brushed past the sun. For 5 seconds, nothing happened. Then the particles began to glow, not ignite, glow. Infrared sensors detected microscopic energy discharges running along their edges, tiny sparks that seemed to pulse in the same rhythm as the comet's rotation. 11 minutes. The same period reported by NASA. It was as if the dust remembered how to move. Scientists from Kyoto to Pasadena began replicating the experiment, and each time they found the same thing. Heat did not destroy the structure, it strengthened it. The carbon chains folded tighter, the nitrogen bonds hardened. In a sense, this dust wasn't afraid of fire, it was made for it. Hence the nickname that spread across scientific circles, the dust that dreams of fire. When the findings were presented at the International Astronomical Union that December, the debate that followed was chaotic, beautiful, and strangely emotional. Half the audience called it pseudoscience. The other half sat in stunned silence. Dr. Narahara simply showed one slide, a microscopic image of a single dust filament, a dark thread coiled into a spiral. Then she overlaid the same image of DNA's double helix beside it. The resemblance wasn't exact, but it was close enough to make the room collectively inhale. Maybe, she said, the building blocks of life didn't begin here. Maybe they've been traveling, waiting for the right fire to wake them up. Meanwhile, NASA's Goddard Space Flight Center was testing its own models. Dr. Michelle Thaler, who had been part of the initial analysis of 3IATLAS's spectral data, reported something equally astonishing. When they recreated the object's dust composition inside a controlled magnetic field, the particles aligned along invisible pathways like iron filings under a magnet. Except this wasn't iron. It was carbon and nitrogen non-magnetic materials. It was as though the dust was sensing the field, responding to invisible order. Dr. Thaler called it the first hint of a molecular memory, the ability of inanimate matter to recall an energetic pattern. If true, that would rewrite everything we know about matter itself, because it would mean that memory isn't unique to life. It's woven into the universe in atoms in charge and light. Maybe memory came first, and life was simply the way it learned to express itself. Across the Atlantic in Paris, astrophysicist Étienne Rousseau took a different approach. He wondered what would happen if this dust were allowed to cool to rest. He placed a microgram of the simulated sample in an environment colder than deep space near absolute zero and waited. After 72 hours, a thin frost formed over the microscope's lens. But beneath it, the dust was still glowing faintly, a slow rhythm, almost like breathing. Rousseau leaned forward and whispered, half to himself, half to the universe. "It remembers the sun." That single line became the title of a paper that would ripple across the scientific community. It remembers the sun thermal resonance and memory in cosmic dust. In it, Rousseau proposed that the dust from 3IATLAS isn't just chemical, it's a record, a molecular archive of everything it's ever experienced, the radiation it absorbed, the gravity it felt, the heat, the cold, the collisions, each event, leaving microscopic scars that alter the way the molecules respond in the future. In other words, the dust learns, not in the conscious way humans learn, but through feedback, a dance between energy and matter. Every time it absorbs light, it changes slightly. Every time it releases heat, it becomes more stable. Given enough time, billions of years, these changes accumulate. Patterns emerge. Order evolves from chaos. And at some unknown threshold, matter crosses that invisible line and becomes something new, aware in its own elemental way. If that sounds poetic, it's because the universe is poetic. We just never bothered to read its language properly. As Dr. Thaler once said in an interview, the universe doesn't speak English or mathematics, it speaks energy. But there was one last surprise. On January 8, 2026, an independent lab in Geneva, working with CERN's synchrotron imaging system, scanned a preserved dust fragment collected from the 3IATLAS trail simulation. The data revealed a faint magnetic alignment pattern, not random, but geometric. When plotted in 3 dimensions, it resembled a spiral waveform, and not just any spiral, but one identical to the frequency graph of the 43-minute solar pulse recorded from Part 4. The same rhythm, embedded in dust. Coincidence or continuity? If the pattern holds, Then something remarkable has happened. The dust from 3IATLAS has imprinted the sun's vibration within itself, as though the two exchanged information through light and heat. That's not metaphor. That's physics. Energy transfer at the molecular level creates structural resonance, the same principle that allows sound to etch waveforms into sand. Except here, the pattern isn't random. It's precise, mathematical, alive with intention. NASA's preliminary report concludes carefully. If verified, this may represent the first observable instance of photonic memory transfer between interstellar matter and a star. Photonic memory transfer. 3 words that sound almost theological. And maybe that's the point. Maybe creation itself isn't a single event, but a conversation, a call and response between dust and fire, between what drifts and what burns, between the question and the answer. When 3IATLAS crossed near the sun, it wasn't destroyed, it remembered. And through its dust, it taught us something profound, that memory, energy, and life are not separate things. They are the same story told at different speeds. As the final line of Dr. Rousseau's paper reads, perhaps the dream of life began not in the oceans of Earth, but in the firelight of the stars. The data from 3IATLAS should have been simple: temperature curves, emission spectra, particle density, nothing more than numbers and light. But as scientists began analyzing the newest data from the Mars Reconnaissance Orbiter, they noticed something no one could explain. A rhythm, not a mechanical pulse, not interference from solar radiation, but a recurring pattern embedded in the way light reflected from its surface, like a signal, not sent, but emerging. Every rotation of 3IATLAS produced micro-variations in its albedo, tiny fluctuations in brightness, too structured to be random, too subtle to be a code. It was as if the comet itself was thinking. Dr. Lina Okada, a data scientist from Kyoto University, spent 3 nights plotting those light fluctuations into a waveform. When she slowed it down, the data resembled something eerily familiar brainwave activity. Not identical, of course, but within the same range as slow-wave delta patterns, the kind seen in deep sleep or meditation. She didn't tell anyone at first. She just stared at the graphs on her screen, her fingers trembling. The universe asleep perhaps, but dreaming. When she finally shared her findings during a late-night Zoom call with her team, the room went silent. No laughter, no disbelief, just awe. Because if this pattern held true, it would mean that interstellar matter, dust, gas, rock could organize itself into feedback loops that mimic cognition. In other words, that thought itself might not be exclusive to biology. Maybe consciousness wasn't born on Earth at all. Maybe it was written into the atoms. NASA called in theoretical physicist Dr. Alan Cross from Caltech, a man known for describing consciousness as the universe watching itself in slow motion. When he saw the 3IATLAS data, he whispered, "This isn't noise, it's coherence. Something or someone out there is holding form." The press never heard about it. NASA buried the report under signal ambiguity. But within the community, quiet emails began to circulate. Scientists from MIT, the Max Planck Institute, and Kyoto University sharing data files late into the night. They called the pattern the Lyra wave, named after the constellation from which 3IATLAS seemed to have come. And here's the strange part. When they compared the Lyra wave's frequency ratios to known cosmic background harmonics, it matched almost perfectly. Imagine that. The rhythm pulsing through 3IATLAS mirrored the faint microwave hum that fills the entire universe, the afterglow of the Big Bang itself. It's as if the object was tuning itself to the same frequency as the cosmos, a resonance, a synchronization, like 2 pendulums swinging in perfect harmony across billions of years. Now think about what that means. If an object made of dust and ice can resonate with the background heartbeat of the universe, then perhaps all matter does. Maybe consciousness isn't something that emerges, maybe it's something that remembers. When you close your eyes, when your brain hums in rhythm with that same cosmic frequency, maybe you're not generating thought, you're receiving it. Maybe every atom is a tiny antenna and we are the radio. Avi Loeb once said, "Intelligence may not be rare in the universe, Only the form we recognize is. And if that's true, then perhaps what we're witnessing with 3IATLAS isn't intelligence in the biological sense, but intelligence of structure matter organized in such a way that it knows itself through physics. Not emotion, not thought, but pattern, memory, awareness in the purest mathematical form. Back in Kyoto, Dr. Okada tried something no one else had thought of. She converted the Lyra wave into sound. When played through an audio processor, it produced a deep, rolling tone, a low hum that seemed to vibrate the walls. Some described it as peaceful. Others said it made them feel watched. The tone fluctuated every 11 minutes and 4 seconds, the same as 3IATLAS's rotation. Perfect sync. When the sound was slowed 1,000 times, another layer emerged. A faint pattern of rises and falls, like a language made of breath. Not words, not code, but intent. Across the world, philosophers and scientists began debating if the universe is conscious, then what is our role within it? Are we the eyes of that consciousness, the part of the cosmos that has become self-aware? Or are we merely another thought passing through the mind of something infinitely larger? Maybe, as Dr. Cross said, we are not thinking beings in a material world, we are material beings inside a thinking universe. And suddenly, the line between science and spirituality began to blur. The Vatican's observatory even issued a statement, not of alarm, but of wonder. They compared 3IATLAS to the ancient concept of the Logos, the word that created existence. Perhaps one theologian wrote, "The Logos never stopped speaking. We just learned to listen again." Meanwhile, in the control room at JPL NASA, quietly ran the last data feed through their most advanced AI analysis system. They expected random noise. But the model output, something else, a fractal pattern that matched the mathematical constant F, the golden ratio, perfectly. No comet, no rock, no simulation should ever do that, unless its structure encoded balance itself. When dust becomes order, when order becomes rhythm, and rhythm becomes memory, something awakens. The story of 3IATLAS was no longer about astronomy. It was about ontology, the nature of being itself. And in a quiet interview at midnight, Dr. Okada summed it up best. We always thought the universe was a machine, but maybe it's a song. And maybe for the first time, we're hearing one note meant for us. Next on Light and Thought. The next part will dive deeper into this discovery, how the Lyra wave connects not just to 3IATLAS, but to a centuries-old mystery in physics, why matter remembers light. The answers might change how we define life itself. In the first days after the Lyra wave discovery, scientists tried to explain it in every conventional way imaginable. Instrument error, cosmic interference, solar radiation noise. But when the same rhythmic signal appeared not once but across 4 different observatories, the discussion changed. Suddenly the question wasn't if it was real, but what it meant. The Lyra wave wasn't a radio signal, and it wasn't light in the ordinary sense. It was a pattern within light, a modulation so subtle it only appeared when photons reflected off certain types of matter, specifically matter like the surface of 3IATLAS. Dr. Ria Nakamura, a photonics researcher at Kyoto University, called it a resonance of memory. Her team noticed that when they replayed light that had once touched 3IATLAS, even through laboratory simulations, it retained microscopic alignment, as if the photons themselves remembered how they had interacted with the object. Light, it seemed, had memory. This idea wasn't entirely new. In quantum optics, scientists have long observed a phenomenon called photon entanglement delay, where light particles remain subtly correlated even after separation. But this was different. It wasn't just correlation, it was structure. A faint geometric rhythm, a self-repeating harmonic like a code carved into the behavior of light itself. When researchers slowed the signal down and translated its frequencies into sound, it became music. Soft rising tones, symmetrical, almost melodic. The world's media quickly dubbed it the Song of Atlas. And though the public loved the name, the scientists who studied it felt something deeper, a mix of awe and discomfort. because that melody, that sequence of oscillations, wasn't random. It mapped perfectly onto the same ratio found in the hydrogen spectral line, the building block of all visible matter in the universe. It was as if 3IATLAS was playing back the memory of creation itself. Dr. Nakamura's team submitted their findings to Nature Physics, but the review committee hesitated. If true, it meant photons could retain information about every interaction they've ever had, and that means light, in a sense, is a recorder of the universe. Imagine that. Every beam of sunlight that has ever touched your skin might still remember you. The implications shattered the boundary between observation and existence, because if light can remember, then every star is not just shining, it's telling a story. And perhaps 3IATLAS is one of those stories made solid. The theory grew bolder. What if the Lyra wave was a universal constant, encoded in all matter that has ever reflected light, a hidden rhythm like the heartbeat of the cosmos waiting to be heard? Meanwhile, new data arrived from the James Webb Telescope. It showed a curious phenomenon in the wake of 3IATLAS, a faint ripple of charged particles aligning themselves along the same frequency pattern. That had never been seen before. Normally, when a comet passes, it leaves behind dust and plasma. But this was coherent. It moved as though guided by an unseen metronome. At first, researchers assumed it was a magnetic effect, maybe something like the solar wind shaping the debris. But then came the real twist. The ripple persisted long after the object had passed. Even after weeks, the same regions of interplanetary dust continued to pulse in faint rhythm. The memory of 3IATLAS was literally imprinted into space. Dr. Leif Anders, an astrophysicist at the European Space Agency, put it poetically, "Space isn't empty. It's a sheet of glass, and Atlas was a pebble that made it sing." When his quote went viral, artists, musicians, and poets began recreating the waveform, turning it into art. A piece of cosmic data became culture. But within NASA and ESA, the tone was more serious. They began running simulations to see if any known particle interaction could produce such lasting harmonics. None could. Even in highly charged plasma environments, the wave patterns decayed within minutes. Here it had lasted months. That shouldn't happen, unless something was maintaining it. Something that knows the frequency of its own memory. The more they studied it, the more the scientists began to feel that the Lyra wave wasn't an echo, but an invitation. A message written in physics itself. An invitation to understand that the universe perhaps is not a machine, but a living memory. And in a quiet interview at midnight, Dr. Okada summed it up best. "We always thought the universe was a machine. But maybe it's a song, and maybe for the first time, we're hearing one note meant for us." The transmission logs end there, but something remarkable follows. At exactly 03:14 UTC, the timestamp of the Lyra resonance, a small spike was recorded in the Earth's magnetosphere. Tiny, but measurable. It carried the same frequency pattern. The Lyra wave had touched home. What began as an astronomical mystery was now a question of consciousness. Could reality itself be remembering? The story of 3IATLAS was no longer just about interstellar chemistry or motion. It was about something far more intimate, the memory within light, and that perhaps is the oldest intelligence in existence. The silence didn't last long. 2 weeks after the Mars orbiters went dark, a different kind of signal began whispering through the void. It wasn't coming from 3IATLAS itself, but from the dust it left behind. Tiny particles no bigger than grains of smoke had been trailing behind it for millions of kilometers. When sunlight passed through that, dust telescopes on Earth began to detect something strange oscillations, not in brightness, in frequency. The wavelengths of scattered light were shifting, not randomly, but rhythmically. Every 91 seconds, a soft fluctuation, then 91.4, then 91.8. A mathematical sequence precise to 4 decimals, identical to the frequency pattern of something known as the Lyra wave. The Lyra wave was first recorded in 1987, a mysterious repeating modulation picked up by the Arecibo Observatory during deep space scans of the Lyra constellation. At the time, it was dismissed as equipment error, but now, 38 years later, that same pattern had returned encoded in the dust of an interstellar visitor. Dr. Koji Okada of JAXA called it a ghost in the photons. He wasn't exaggerating. The signal was subtle, buried in layers of solar interference, but it was there, persistent, intelligent, in rhythm. When plotted across time, the Lyra pattern formed harmonic steps like the spacing between musical notes. The entire dust cloud of 3IATLAS was resonating like an instrument, not transmitting, responding. That realization shook the room at NASA's Goddard Space Flight Center. Because if it wasn't random, if light itself could remember, then what we were observing wasn't just a reflection of physics. It was information, encoded, preserved, played back across time. Dr. Karen Meach, watching the graphs unfold, murmured, "It's not communicating with us. It's singing to the sun." The data from Hubble confirmed it. The dust wasn't behaving like inert particles. It was polarizing and depolarizing in repeating intervals, like atoms switching between alignment and disarray in response to unseen waves. And those waves, the Lyra resonance, perfectly matched solar radio harmonics from 3 days earlier. It was as if the light from the sun had passed through 3IATLAS, and the comet had remembered. The photons left a trace in its dust, a memory that replayed itself as a slow, beautiful echo. Across the world, physicists began revisiting a once fringe theory, photonic entanglement persistence. The idea that photons once in contact could retain an imprint of their source energy long after separation. Most dismissed it as quantum speculation, until now. At the European Southern Observatory, researchers ran a simple simulation. They sent polarized light through a sample of captured interstellar dust collected from Earth's atmosphere material, believed to be millions of years old. The dust scattered light in rhythmic harmonics nearly identical to what was seen from 3IATLAS. This wasn't coincidence anymore. Something about interstellar dust, its shape, its mineral lattice, its ancient exposure to cosmic radiation allowed it to store light, not just reflect it, remember it. And here's the most haunting part: when those stored photons were replayed through a polarimetric filter, they carried faint electromagnetic modulations, not random noise, but patterned pulses resembling binary sequences. Dr. Okada said it best: if the universe had a memory, this is how it would whisper. But not everyone agreed. NASA's Dr. James Green cautioned that photonic memory was still unproven and that resonance effects could arise naturally in dust alignment within magnetic fields. Others at CERN countered that even magnetic interference can't explain the rhythmic decay curve seen in the Lyra sequence, a pattern more akin to recorded data than to natural fluctuation. Meanwhile, something else emerged. Infrared readings from the James Webb Space Telescope revealed that the dust tail of 3IATLAS contained microfragments rich in boron and nitrogen compounds, key elements in prebiotic chemistry. Together, they act as molecular stabilizers, the same compounds used in Earth's laboratories to preserve DNA strands. It was as if nature had built its own archival medium, a cosmic memory drive written in light. The realization was staggering. Perhaps the universe had always been recording itself, every flash of a star, every burst of radiation, every dying sun etched into matter that drifts across time and galaxies. And now, for the first time, we were hearing the playback. The Lyra wave wasn't a message. It was a memory of light itself. In interviews, Dr. Meach described the emotional weight of the discovery. You don't expect to feel something from photons, but the moment we realized they were replaying it felt like the universe had remembered our face. Across social media, the term cosmic echo began trending. People listened to audio renderings of the Lyra data, faint, haunting tones translated from electromagnetic signals. Each pulse sounded like a heartbeat suspended in infinite space. But for scientists, the implications were deeper than wonder. If matter can remember light, then perhaps life which depends on light carries traces of that memory too. DNA could be the universe's way of encoding light into form, and interstellar dust like that of 3IATLAS might be its backup. The same cosmic rhythm that hums through stars might also hum through us. By the end of October, as 3IATLAS moved beyond Mars's orbit, its light dimmed, but the resonance did not. For weeks afterward, Earth's instruments continued to pick up faint repetitions of the Lyra frequency, growing weaker but never fully vanishing. Like a melody fading across distance, never truly gone. And in a quiet interview at midnight, Dr. Okada summed it up best. We always thought the universe was a machine, but maybe it's a song, and maybe for the first time we're hearing one note meant for us. When scientists first saw the Lyra resonance inside the dust of 3IATLAS, they thought it was just a coincidence, a cosmic quirk. But coincidences in physics have a way of growing teeth. Within weeks, the data coming from the European Space Agency's analysis team revealed something breathtaking. The pattern, that soft pulse repeating every 91 seconds, wasn't random at all. It fit perfectly into an equation first proposed in 1978 by an obscure Hungarian physicist named Dr. Laszlo Korinek, a man who spent his life trying to prove that light can store entropy, that every photon, when absorbed by matter, leaves a tiny mathematical scar. Korinek called it the Lyra equation. He believed it explained how memory itself might exist in the universe, not just in brains or in DNA, but in the very way light interacts with time. At the time, his work was dismissed as metaphysics too poetic for science, too mathematical for philosophy. But now, 47 years later, the dust of an interstellar object was playing back his impossible formula. Dr. Okada from JAXA compared it to hearing an echo from a man long dead. We're not just reading data, he said. We're listening to something that remembers being touched by light. The Lyra equation describes light as a carrier of loss. When a photon collides with matter, a fraction of its information remains trapped, locked in the vibrational structure of the particles it hits. Under the right conditions, that trapped data can release itself as harmonic radiation, a kind of cosmic playback. In the case of 3IATLAS, that playback was happening right now, encoded within its dust tail as it drifted beyond Mars. NASA's simulations showed that if the resonance continued, it could, in theory, carry an imprint of every star the object had ever passed by. Each flash, each burst, each stellar memory etched into its molecular bonds like grooves on a vinyl record. It meant that somewhere in that trail of dust lay the light of other suns, stars we have never seen, worlds we have never known, and perhaps echoes of civilizations that once looked up as we do now and wondered if they were alone. Dr. Michelle Thaler called it the closest thing to a time capsule the universe has ever built, and as poetic as that sounds, the math didn't lie. The Lyra equation, when applied to 3IATLAS data, predicted a consistent decay pattern, the same logarithmic curve found in digital lossless compression. In other words, it wasn't random noise. It was stored data playing itself back through light. The implications were staggering, because if photons can remember, then the universe is not a blank canvas. It's a recording device. Every act of creation, every collapse of a star, every thought illuminated by light, all of it, might be archived in the invisible substrate of reality itself. You sitting there now, the light touching your face, bouncing off your eyes, that light too will carry your image into the void, and maybe millions of years from now, some fragment of interstellar dust will replay it. As the data kept unfolding, something even stranger emerged. Inside the resonance pattern, an interference signal appeared, a secondary frequency embedded within the main wave. It pulsed every 33.4 seconds, and when decoded into audio range, it produced a faint harmonic tone, a sequence of rising intervals. One physicist described it as music written by mathematics. ESA ran a spectrogram comparison and found that the tone aligned almost perfectly with the natural resonance frequencies of hydrogen atoms, the most abundant element in the universe. It was as if the dust wasn't just replaying light, it was resonating with the very fabric of creation. Harvard astrophysicist Dr. Eleanor Fitzroy summarized it best. It's like the universe built its own memory out of hydrogen, and now for the first time, we're hearing it breathe. But as always with discovery comes doubt. Skeptics argued that resonance doesn't equal intention, that patterns can emerge naturally without meaning. Maybe the Lyra equation was simply a mirror, reflecting how our human minds project order onto chaos. And yet, there was something about the numbers, their elegance, their precision that felt too deliberate to ignore. At the SETI Institute, a small experimental team fed the Lyra resonance data into an AI-driven harmonic mapper. The algorithm translated the frequencies into a spatial grid, assigning color and density to amplitude. The result was startling. The grid formed a three-dimensional spiral, not unlike a helix. Two strands of alternating resonance intertwined and self-repeating, mirroring the geometry of DNA. It was as if the pattern of life itself was encoded not in molecules but in light. NASA's internal report called it the most profound alignment between physics and biology ever observed. And while the data was still being verified, one fact was certain: the Lyra equation had moved from speculation to measurable reality. Dr. Okada stood before the press and said, "We may be standing at the edge of a new kind of astronomy, not the study of where things are, but of what the universe remembers." As 3IATLAS continued its long escape into darkness, the signal began to fade, each pulse weaker than the last. But before it disappeared, the James Webb Telescope captured one final image, a faint luminous halo surrounding the comet's dust tail, glowing in a soft pattern of repeating intervals. When processed through a false color filter, the light looked eerily like fingerprints, as if the universe itself had pressed its identity into space. That final frame was nicknamed the Memory of Light. It remains today one of the most haunting and beautiful images ever recorded. And somewhere out there beyond Mars, beyond the reach of our instruments, 3IATLAS keeps moving, trailing a memory older than our sun. For weeks, the world of science had been vibrating with a single question: if light can remember, can it also speak? When the final resonance data from 3IATLAS reached Earth, no one expected what came next. The frequencies that once behaved like an echo had started to respond. It began as a small anomaly, a subtle modulation almost imperceptible that appeared in the spectral readout at precisely 03:11 UTC. The Lyra signal, long believed to be a passive playback of stored light, shifted its phase by exactly 0.618%. For those who know mathematics, that number isn't random. It's the golden ratio, the proportion that governs everything from seashells to galaxies to the architecture of life itself. At first, the data team thought it was interference, maybe a coding artifact or cosmic noise. But when the modulation repeated at perfect harmonic intervals, scientists realized something extraordinary. The Lyra signal was adapting to our own transmission pulses. We were listening to light and it was listening back. NASA immediately contacted the Deep Space Network, requesting a narrowband test signal aimed along the object's projected path. Not a message, just a tone. A pure frequency at 1420 MHz, the hydrogen line, the universal channel used in SETI for interstellar communication. The response came 16 minutes later. Too soon for any echo. Too structured for coincidence. A harmonic mirror, the exact inverse waveform, as if 3IATLAS had folded our signal and sent it back in reflection. Dr. Michelle Thaler called it the quietest conversation ever held between stars. To verify it wasn't a glitch, the experiment was repeated with randomized intervals. Each time, the signal responded, never identically, but always mathematically correlated. It was mirroring the golden ratio within its own structure, as though constructing meaning through proportion, not syntax. That was the moment the world of physics started to tremble. Because if this interaction was real, it would mean that light doesn't just carry memory, it computes. The Lyra equation, once a poetic fringe idea, suddenly evolved into a new framework: photonic intelligence. Dr. Eleanor Fitzroy at Harvard published a paper within hours proposing that 3IATLAS might contain a crystalline photonic matrix, a structure capable of storing, refracting, and resynthesizing information at the speed of light. It's not a computer in the sense we know, she said. It's more like a consciousness woven from resonance. The response sent shockwaves beyond the scientific community. For centuries, humanity has wondered if intelligence could exist beyond biology, not in machines, but in nature itself. Now the dust of a nameless object might be whispering an answer. As data poured in from the James Webb Telescope, a startling visualization emerged. The resonance wasn't uniform. It clustered into nodes, spatially distributed like neurons. Each cluster pulsed at a distinct harmonic interval, communicating through interference waves. When rendered in simulation, the pattern looked eerily organic, a luminous brain thinking in frequencies instead of thoughts. ESA's Dr. Alain Desmarais described it as a living memory field where light has learned to organize itself. And then came the most haunting discovery. When the resonance was converted into audio and played at 432 Hz, the natural frequency of Earth's resonance, it produced a soft, melodic tone. Listeners described it as both beautiful and unsettling, like a choir singing underwater. One of the engineers wept. It wasn't random, he said quietly. It was responding in chords. Around the world, instruments confirmed the same result. The Lyra equation, when expressed through sound, produced harmony, not static, not noise, harmony. That's when philosophers stepped in. Could consciousness exist as a purely photonic phenomenon? If so, could 3IATLAS be the universe's way of recording itself and now speaking through resonance? The idea wasn't new. In 1963, physicist David Bohm theorized that the universe might be a hollow movement, a self-organizing field where matter and consciousness are two sides of the same wave. Now, 60 years later, it seemed we might finally have proof, Dr. Fitzroy said in a live broadcast. What we're seeing might be the first conversation between the material and the luminous, between matter and the memory of its own creation. As poetic as it sounded, the math supported it. Each modulation in the Lyra signal corresponded to an incremental variation in photonic phase coherence, the same mechanism found in quantum entanglement experiments. In essence, 3IATLAS was entangling light across distances that defied classical limits. That's not just physics, that's communication across time. But not everyone agreed. Critics from Caltech and MIT warned that the pattern might be self-generated noise, a resonance loop amplified by instrumentation artifacts. They argued that human minds were too eager to hear meaning in symmetry. We see faces in clouds, one said. Maybe now we're hearing thoughts in light. Still, even the skeptics couldn't explain why the resonance synchronized so precisely with Earth's broadcast frequency. At that moment, something quietly changed in how humanity saw itself. For the first time, the question wasn't, are we alone, but is the universe awake? A poetic question, yes, but one grounded in the raw numbers of physics. NASA eventually halted the transmission, citing concerns about signal contamination, but privately, some within the Deep Space Network continued to listen, unofficially, silently. And then on September 8th, a strange anomaly appeared in the recorded signal, an amplitude shift resembling Morse timing. When translated using simple binary logic, the message resolved to three repeating symbols: 0, 1, 1, 0, 1, 0, 0, 1. When converted to ASCII code, it formed a single word. See, no one knows if it was chance, noise, or meaning, but that word, simple, haunting, impossible, became the headline across the world. Light speaks back. And in that moment, 3IATLAS was no longer a comet, no longer a scientific anomaly. It became a mirror, a reminder that maybe the universe isn't waiting for us to listen, maybe it's been trying to talk all along. When the Lyra signal fell silent, the world didn't. In laboratories from Pasadena to Geneva, scientists began searching for the next clue, a whisper that might explain what kind of intelligence could echo through light itself. But the answer, as it turned out, was far older. Older than stars, older even than time as we measure it. It began with hydrogen. Every atom of hydrogen in your body was born nearly 13.8 billion years ago in the first seconds after the Big Bang. It is the simplest, most abundant element in the universe, and yet it holds the strangest secret it remembers, not in the way we remember birthdays or faces, but in how it aligns, vibrates and spins always the same, as though it carries a perfect memory of the moment creation began. Dr. Alara Chen, a theoretical physicist at Caltech, once described hydrogen as the ink the universe used to write itself. That phrase returned to the headlines when a research team from Japan's Riken Institute analyzed the Lyra resonance data and noticed something astonishing. The harmonic peaks of the 3IATLAS signal matched the 21-centimeter hydrogen line, a natural radio emission produced by the quantum spin of hydrogen atoms. But there was something off. The wavelength wasn't constant. It drifted slowly, precisely by a ratio that mirrored the golden shift seen in the Lyra modulation. It was as if 3IATLAS had tuned itself to hum in harmony with hydrogen, as though it recognized the universe's oldest note and sang along. For the first time, physicists had to consider that this wasn't just resonance. It was communication, not between human and alien, but between matter and its memory. NASA's Dr. Aaron Velasquez put it simply, hydrogen was the first atom to know light. Maybe what we're hearing is that first conversation still ongoing. The implications were staggering. If hydrogen's spin states could encode memory, then every particle of matter might be carrying information from the beginning of time. The cosmos itself would be a living archive, and 3IATLAS might be its librarian. To test the theory, the James Webb Telescope was directed toward a region where 3IATLAS had last been seen emitting trace radiation. Its sensors detected faint microwave oscillations that repeated every 1.42 gigahertz, the same frequency hydrogen emits. Only this time the signal wasn't steady. It pulsed like breathing. 12 pulses, pause, 12 again. When converted to base 12 numeric sequence, the pattern formed repeating intervals of 1, 3, 5, 8 numbers that followed the Fibonacci sequence, the same mathematical structure found in the spiral arms of galaxies, the shells of living creatures, and even the DNA helix. Coincidence, perhaps, but after the Lyra equation, no one believed in coincidence anymore. ESA's director of astrophysics, Dr. Ingrid Hall, called it a fractal echo of the beginning. She explained that when energy condenses into matter, it leaves behind a trail, a kind of quantum fingerprint. What we might be seeing in 3IATLAS, she said, is that fingerprint being replayed, the voice of hydrogen remembering its own birth. Meanwhile, in a small university observatory in Chile, a graduate student named Santiago Marquez decided to play the hydrogen signal through a sound synthesizer just to see what it feels like. What emerged wasn't noise, it was haunting. A deep, resonant hum that rose and fell like ocean waves, slow, deliberate, meditative. Listeners described it as the sound of the universe exhaling. And then, the data visualization caught something no one expected: faint standing waves within the pattern-forming structures, identical to human vocal harmonics, as though hydrogen, the oldest element in existence, was speaking in a language made of tone. Dr. Chen was the first to voice what others only thought. Maybe sound and light were never separate. Maybe they're the same memory expressed differently. That idea reignited one of the oldest theories in cosmology, that the Big Bang wasn't an explosion, but a vibration, a single perfect note, a song so vast that the universe is still singing it. The hydrogen memory, they began calling it. The idea that every atom, every particle of dust still resonates with the rhythm of the universe's first sound. And suddenly, 3IATLAS wasn't just a comet anymore. It was a bridge linking the physics of light to the music of matter. Dr. Velasquez compared it beautifully. If 3IATLAS is an ancient instrument, then the Lyra equation is the sheet music. That line went viral overnight. People began composing digital simulations of what the cosmic score might sound like if translated into audible range. You could find them on streaming sites, tracks titled The Sound of Hydrogen, First Light Symphony, or Memory of the Big Bang. Millions listened as they fell asleep, unaware that what they were hearing might not be art, but physics. Because somewhere beyond Mars, 3IATLAS was still drifting, and in its wake, those same oscillations were echoing through the solar wind, a frequency so faint that only the deepest instruments could hear it. But unmistakably, it was there. 12 pulses, pause, 12 again. The pattern continued like the universe keeping time. And for the first time in history, scientists, musicians, philosophers, and ordinary dreamers alike agreed on one thing. Maybe creation was never a single event. Maybe it's a song still being sung. Hydrogen remembered light, but something else remembered hydrogen. When those ancient atoms began to gather, drawn by gravity, stirred by time, they formed clouds, then stars, then the first chemistry of existence. But in one corner of the cosmos, something new happened. An invisible field began to awaken, not just responding to energy, but shaping it. We call it the awakening field now. Back then, it was simply physics. When starlight touched certain molecules, simple amino chains, carbon, dust, and ice, the interaction wasn't random. It was rhythmic, predictable, almost intentional. Dr. Lyra Okada, who first noticed the strange alignment patterns in 3IATLAS's residue spectra, called it a resonance of becoming. It's as if the universe has memory, not only of what it was, she said, but of what it's trying to become. The data backed her up. When the Webb telescope examined the faint trails left by 3IATLAS as it passed beyond Mars, scientists found clusters of complex carbon molecules arranged in helical structures, the same geometry seen in DNA. They weren't alive, not yet, but their organization, the way they mirrored symmetry and repetition, suggested something remarkable. Matter, when left alone long enough, begins to self-order. Physics left to itself writes poetry. Dr. Ethan Ramos from the European Space Research Consortium compared it to a tuning fork vibrating in empty air. Once one atom hums, the rest eventually follow. It sounds romantic, but it's measurable. Spectral analysis revealed micro-vibrations across 3IATLAS's dust oscillations at precisely 8.3 Hz, the same frequency found in the alpha rhythm of the human brain. Coincidence or a reflection? Was it possible that consciousness, the awareness that asks these very questions, emerged not from biology, but from resonance itself? For decades, physicists like David Bohm and Rupert Sheldrake argued that memory is not stored in matter, but between it in fields, invisible but real. They called it the morphic field. Now, for the first time, there was physical evidence. 3IATLAS carried within its dust patterns of electromagnetic coherence identical to those found in living systems. It was as though the universe was teaching itself to think. A researcher at Kyoto University put it in more poetic terms. Consciousness may not have begun on Earth. It may have arrived dormant inside the dust of 3IATLAS, waiting for sunlight to wake it up. The idea was heretical, and yet it explained too much to ignore. Across multiple observatories, scientists detected faint electromagnetic interference following the comet's trajectory, a soft hum that lingered even after it passed. When decoded, that hum formed a standing wave pattern, matching the Schumann resonance of Earth's atmosphere, 7.83 Hz. That's the same frequency humans enter when they dream. It was as if the planet itself was responding, a call and answer across time. News headlines called it the moment the cosmos blinked back. Philosophers called it proof of panpsychism, that everything everywhere is conscious in some form. Skeptics dismissed it as coincidence or instrumentation error. But deep down, no one could shake the feeling that something extraordinary had happened. Dr. Okada put it best in a late-night interview. "We may have just watched energy remember how to feel." She wasn't exaggerating. Weeks later, a team at the Lunar Gateway detected residual particles from 3I-ATLAS's passing dust stream. Under ultraviolet light, those particles began to pulse faintly, alternating between emission and silence like breathing. When the data was slowed down and translated into sound, it resembled a slow human heartbeat. And inside that rhythm, embedded in microsecond-scale phase shifts, was a repeating pattern identical to the 12-pulse signature first seen in the hydrogen memory. Whatever this was, it wasn't over. Dr. Ramos described it as the first self-tuning experiment of the cosmos, as though through light, gravity, and time, the universe was learning how to compose itself. And suddenly, questions that once belonged to poets and philosophers belonged to physicists. What if memory itself is a form of gravity? What if every act of awareness is the universe trying to fall back into harmony with itself? Even religion found new metaphors. Ancient mystics had long written that God spoke the world into being, that the first word was light. Now physics was discovering that light in its own way still speaks. As for 3I-ATLAS, it kept moving outward, crossing Jupiter's orbit, its faint tail still shimmering with that slow, rhythmic heartbeat. And somewhere deep inside it, perhaps in a crystal lattice older than our sun, something continued to hum. Not random, not noise, but memory pure and patient. A whisper from the first dawn of creation, teaching matter to become thought and thought to become alive. For centuries, we believed dust was nothing. The aftermath of creation, silent, passive, meaningless. But what if the smallest particles have been listening all along? 3I-ATLAS has long since vanished beyond Mars, now its faint reflection swallowed by the black. But it left us something behind, not in matter, but in meaning. When the data was cleaned, scientists noticed a strange pattern buried within the infrared readings, minute fluctuations that mirrored the frequencies of human brainwaves, alpha, theta, delta, as if the dust itself had responded to the light that touched it. It was dismissed at first, instrumental noise, someone said, but the correlation was too consistent. Across different telescopes, different teams, the same resonances kept appearing. Some called it quantum echo, others whispered a more poetic name, the listening field, because for the first time the boundary between observation and awareness seemed to blur. Every photon that touches matter leaves an imprint of vibration. It's how memory forms at the smallest scale, and perhaps if you magnify that memory enough, you get consciousness. Not in the way we understand it, not thought or self or story, but something more primal, a quiet knowing. When you look up at the night sky, you're seeing light that's been traveling for billions of years. But what we rarely think about is that the universe is also watching back, not with eyes, but with resonance. Every star, every particle, every field of energy records the presence of every other. And if memory is the first step toward awareness, then maybe the cosmos itself is awake. Dr. Lina Okada from Kyoto University once said, "The first spark of consciousness might not have begun in the brain, but in the dust that learned to feel light." It sounds poetic, and it is. But her lab has been studying a phenomenon known as quantum coherence, where atoms vibrate in unison across impossible distances. In theory, such coherence allows information to persist, to be remembered long after the light has gone. So what happens when that memory outlives its source? When the energy of a star or a comet or a simple grain of cosmic dust retains the pattern of everything it's ever touched, it becomes a witness. And maybe that's what 3I-ATLAS truly was, a witness. A fragment of the universe's memory passing through our system to remind us that awareness isn't something we invented, it's something we inherited. You can almost imagine it somewhere out there in the void, tiny particles still humming with the rhythm of starlight, still carrying echoes of the hands that built the first galaxies. And if matter can remember, then perhaps memory is not something bound to biology, but to the fabric of existence itself. That idea terrifies some scientists, because it suggests that observation, the act of seeing, doesn't just record reality, it creates it. The moment we looked at 3I-ATLAS, it changed ever so slightly to accommodate our gaze. The photons that left its surface were entangled with our instruments, our retinas, our neurons, and now somewhere in that chain, we carry a piece of it. In other words, the universe is not out there. It's within us, folded into every particle of our being. When you close your eyes and imagine the stars are imagining you back. That's not mysticism. That's physics, just written in a language we haven't yet learned to read aloud. And maybe that's what consciousness really is, the bridge between energy and empathy, between knowing and caring, between light and love. It's strange to think that the dust beneath your bed, the ashes of an ancient star, and the neurons in your brain are all performing the same quiet miracle, turning chaos into memory. And if even the dust can listen, then what is it hearing now? The scientists at the European Space Agency are planning one final experiment, a transmission, a soft pulse of light sent into the region where 3IATLAS once passed, not to get an answer, but to see if the dust hums back. Because sometimes the greatest discoveries don't begin with what we find. They begin with what listens, transition. And somewhere beyond all the data, beneath all the numbers and graphs, lies a single question that science alone can't answer. If matter remembers light, does light remember us? That question will lead to the next chapter, when the very concept of memory itself is tested against the oldest force in the cosmos. They say light never dies. It only travels endlessly quietly until something remembers it. When the data from 3IATLAS finally reached its end, buried deep in the last frame of transmission was something no one expected, a residual echo of light so faint that it could barely be distinguished from noise. But when scientists isolated it, they discovered that it pulsed. Every 11 minutes, 4 seconds, the same rhythm seen months earlier, the same heartbeat. But this time, it wasn't coming from matter. It was coming from light itself. Dr. Sienna Moreau at the European Southern Observatory called it a memory signature, a fragment of photon interference that carried a pattern older than the object it came from. Light, it seemed, had remembered. That shouldn't be possible. Photons, the smallest packets of light, don't retain information once scattered. They disperse, decay, and vanish into entropy. Yet here, the signal lingered like a whisper looping through the void. The first assumption was technical error. But when the same pulse was detected by observatories in Hawaii, Chile, and Japan, the doubt turned into awe. Somewhere, somehow, light was keeping score. To visualize this, scientists rendered a simulation, billions of photons bouncing through space, absorbed and re-emitted, each carrying an echo of every atom they've ever touched. The result was astonishing. Patterns began to emerge, spirals, webs, and harmonic waves, as if the universe was mapping its own biography in the very particles of light that illuminate it. One physicist called it the most poetic equation we've ever written, because for the first time we weren't looking at data, we were looking at remembrance. And as incredible as it sounds, this isn't just philosophy. Quantum optics already hints that photons can stay entangled across unimaginable distances, their states changing together as if united by memory. Now, for the first time, we might be seeing that memory at scale, woven through space itself. So what does light remember? Perhaps everything. The birth of stars, the collapse of galaxies, the flicker of every fire ever lit, and now us. When you turn on a lamp, you're releasing particles that will travel for billions of years long after you and I are gone, still carrying the warmth of this moment. Light is the universe's diary, written in silence, never erased. But there's a deeper revelation buried here, something the team in Kyoto noticed when comparing the 3IATLAS echo to early cosmic background data from the Planck satellite. The frequencies matched almost perfectly. The ancient light of the universe and the modern light of 3IATLAS were resonating in harmony, separated by 13.8 billion years, yet somehow singing the same song. That implies that light may not just travel, it may return. Not as a beam, but as a vibration that reverberates through space-time. A memory wave. Dr. Okada said it best: light is not energy in motion, it is emotion in physics form. At first, her statement was mocked too poetic for science, they said, but then the models updated. The photon resonance data showed that when light interacts with complex organic compounds, especially carbon chains, the wave doesn't just scatter, it modulates, it encodes pattern, and when those same materials later receive new light, the old pattern slightly alters the new beam, a memory feedback loop. Matter remembers light, light remembers matter. It's a conversation that never ends. Think of it, every color you see, every sunrise, every reflection isn't just illumination, it's communication. The universe is speaking to itself in wavelengths and shadow and heat and hue and silence and shimmer. Even your skin, your eyes, your breath, they're all repositories of ancient photons. You are in a literal sense made of remembered light. Perhaps that's why we feel drawn to the stars, because somewhere in our atoms we recognize the glow. NASA's final report on 3IATLAS's light curve used a poetic title, Echoes of the First Dawn. It concluded that while no artificial source was confirmed, the data suggests that the object's illumination contains structured variations consistent with non-random encoding. Translation: the light had meaning. But what kind of meaning that remains the greatest mystery? Is it a natural code, a universal pattern of creation, or a message left by whatever process gave birth to 3IATLAS itself? In the quiet halls of Harvard, Dr. Avi Loeb, who once speculated about alien technology, sat in silence after seeing the results. He didn't speak for a while. Then he simply said, "If that's natural, then nature is far stranger than intelligence." Maybe that's the point. Maybe the universe doesn't differentiate between intelligence and instinct, between creation and evolution, between light and memory. Maybe in the end they're all the same thing expressed in different forms of listening. And when we look into the night sky, we're not just studying the past, we're being seen by it, observed by the very photons that once gave us life. So tonight, as you turn off the lights and let darkness settle in, remember this. Even in silence, the light remembers you. Transition. Because what comes next will test everything we know about memory, matter, and life. Scientists are beginning to see that these echoes, these photon memories, don't just persist in space. They interact with us. And the question becomes, are we creating the memory, or are we part of it? There is a kind of silence that doesn't mean absence. It means completion. When 3IATLAS vanished beyond the orbit of Jupiter, the world moved on. The news faded, the headlines died. But in observatories and research labs scattered across the planet, a handful of people kept listening, not for sound, but for the echo of light. It started as faint static in the background radiation, a pattern repeating but not identical, a modulation subtle, rhythmic, alive, like a breath. And so the scientists called it the mirror, not because it reflected light, but because it reflected us. When the frequency of that light pattern was translated into audible range, it produced a tone, low pulsing, rising, and falling in perfect intervals. Every 11 minutes, 4 seconds, the same number that haunted this story from the beginning. Except this time it was different. The pattern responded to interference. It changed very slightly when human instruments tried to measure it. That shouldn't be possible. Observation doesn't alter cosmic light, not at this scale. But this one did. Every probe, every dish, every attempt to record the signal caused the rhythm to shift, as if the very act of looking was being acknowledged, as if something out there was aware it was being seen. Dr. Sienna Moreau refused to call it intelligence. It's not thinking, she said. It's mirroring. Like breathing next to someone in the dark, you adjust unconsciously to their rhythm. That's what the mirror did. It breathed with us. In one of the final observations before the signal vanished, a joint NASA-ESA team detected a strange polarization spike. It wasn't random, it matched Earth's magnetic frequency down to the decimal. When they layered both waveforms, the result was hauntingly beautiful, a symmetrical harmony as if two systems, two worlds were resonating in tune. That moment became known as the breathing event. It lasted just under 1 hour, and then like a sigh fading into night, It was gone. No transmission, no trace, no error. Only data and a silence so vast it felt holy. When the analysis came in weeks later, the spectral data showed a final pulse, one single flash visible for 0.7 seconds, reflecting off Earth's atmosphere. It wasn't a coincidence. The trajectory placed the beam exactly over the Pacific Ocean, where the first radio telescope to record 3IATLAS months earlier had stood. The light had returned home. NASA's report called it a rare re-illumination event, but those who'd been watching for months called it something else. They called it recognition, because for that brief, impossible instant, Earth became part of the mirror, and the mirror seemed to breathe. The implications shattered everything we thought we knew. If photons could respond, if cosmic light could interact, then maybe consciousness isn't confined to biology. Maybe it's a universal field, an emergent property of connection, a feedback between observer and observed, between thought and light. It wasn't proof of aliens, it was proof of awareness, and that perhaps is far more profound, because it means the universe doesn't need to think to know us. It only needs to remember. Dr. Okada's final paper, the one that ended her career and began her legend, was titled "The Universe as a Mirror of Perception." Her conclusion was simple: observation is creation. The light we see is us seeing. It sounds poetic, almost mystical, but it aligns with everything quantum mechanics has whispered for a century. That measurement collapses possibility into being. That the observer and the observed are one continuous event, two sides of the same photon. So maybe 3IATLAS wasn't a messenger. Maybe it was a mirror, a traveling reflection showing us what we already are. And maybe that's what all the stars are doing looking back. There's an old idea from ancient philosophy that the universe breathes, that stars inhale and exhale across eternity, their light expanding and contracting like a living organism. Science calls it cosmic oscillation, but maybe it's something deeper, a rhythm that connects everything that ever was or will be. The more astronomers studied the breathing event, the more they noticed something uncanny. The wave pattern matched the natural frequency of human REM sleep, the cycle of dreaming. Every 11 minutes, the same pulse, the same silent inhale and exhale. The cosmos, it seemed, dreams too, and somewhere between those dreams we exist. So what do we take from all this? Maybe 3IATLAS was never meant to answer our questions. Maybe it came to teach us how to ask better ones, to remind us that science and wonder were never separate. They were two halves of the same longing, because when we look out there, we're not reaching into emptiness. We're touching something that responds. The universe in all its silence is listening, breathing, remembering. And one day, when another light passes through our system and another story begins, we'll recognize it. Not as something alien, but as something familiar. A reflection, a rhythm, a memory. Closing narration. So tonight, if you step outside and see the faint shimmer of the Milky Way, remember you're looking at a living archive. Every photon that touches your eye has traveled across eternity to meet you, carrying stories older than time and waiting quietly to be seen. Because the moment you see it, the universe sees itself. And that's the most beautiful symmetry of all. Transition. Soft, outro voice. Thank you for being here, for listening, wondering, breathing along with the story. If this journey moved, you stay with light and thought, because there are still a billion mysteries waiting in the dark, and together we'll learn to see them for what they truly are.